This is section 252. We're going to take a look at a system of equations with two variables. So we're going to solve a system of linear equations with substitution, and we're going to solve a system of linear equations with elimination. Now there are two ways for us to solve a system of equations algebraically. We can use the substitution method, and we can use the elimination method. The substitution method is you plug in what a variable equals in one equation into the other equation. It sounds a little weird, but when we go over it, it'll make a little more sense. And then the elimination method is you're going to add the equations together to eliminate a variable. Okay, so it's like when we add them together, we want it to cancel out. So let's look at this first one. We're going to examine substitution. So because I have a variable that's by itself, y equals 2x plus 1, or y equals negative x minus 5. The substitution method says that I can plug in what y equals into the other equation. So since I know that y equals negative x minus 5, I can plug in what y equals in for y into the other equation. And so it would look like negative x minus 5 equals 2x plus 1. Now this used to be the y, and I substituted what y equaled from the other equation into it. Now once you do that, all you have to do is just continue to solve. So we want to get x by itself, so I can add x to both sides. So negative 5 equals 3x plus 1. Subtract. So negative 6 equals 3x. And so x equals negative 2. Now I need to find what y is, so I can plug in what x is into one of the equations. Now it doesn't matter which one you do, just look at which one you feel is easiest and use that one. So then y equals 2 times negative 2x plus 1, so y equals negative 4 plus 1, so y equals negative 3. Now we found what y is, we found what x is. If you remember from integrated 1, the solution to a system of equations is where they intersect, which means it's a point. So we have to write our answer as a point. And so if we look at this visually, if I graphed both of these, this is where they intersect. They intersect at that point that we just found, negative 2, negative 3. Let's look at another one. So y equals negative 3x plus 5, and 5x minus 4y equals negative 3. So substitution, I'm going to substitute what y equals is in this case into the other equation. 5x minus 4, and then in parentheses, the negative 3x plus 5, and that's going to equal negative 3. So remember, this is what y was, and I substituted what y equaled from the other equation into it. Now you can also do the same thing for x. If it said x equal, then you can plug in what x was. So now we need to find x here. So distribute, so 5x plus 12x minus 20 equals negative 3. So add 20, combine those together. So that's going to be 17, and so x equals 1. So now plug it back in. I feel the top equation again is going to be the easiest. So y equals negative 3 times 1 plus 5. And so that's going to equal negative 3 plus 5, which is 2. So remember, this represents where the two lines intersect. And so we have to write it as a point. And so visually, if we were to graph both of them, as you can see, they intersect at 1, 2. So now we're going to go into the elimination method. So as I said previously, you add the equations together to create a new equation. Now when you add them together, you want to make sure a variable disappears. So to know if a variable is going to cancel out, they need to be opposites of each other. So if you notice, this says x and 2x, not opposites. This says negative y, this says positive y. Those are opposites of each other. So I know that if I add these equations together, what's going to happen is they will cancel out. And so if I do that, I'm going to get 3x, the y's cancel out, equals 30. Now I can solve for x, divide both sides by 3, you get x equals 10. So now I can plug x back in. So if I plugged it into here, 2 times 10 plus y equals 19. That's 20 plus y equals 19. Subtract 20, you get y equals negative 1. And so remember, we need to write it as a point. And so comparing it to our graph, if we see there, it's 10, negative 1. Now, if we're looking at this one, if we notice, these are not opposites of each other, and these are not opposites of each other. So because they're not opposites, when I add them together, they're not, like, a variable won't cancel out. Another rule to the elimination method is we're allowed to multiply an equation by any number to create a new one. So I can multiply this top equation by negative 1, and if I do that, I get 6x minus 6y equals negative 6. The bottom, nothing happened, stays the same. So now the x's are opposites. So when I add the equations together, you're going to get negative 3y equals negative 18. Divide both sides by negative 3. You're going to get y equals 6. Now we have to find x. So if we plug it back in, say if I plug it into the bottom one, negative 6x plus 3 times 6 equals negative 12. So negative 6x plus 18 equals negative 12. Minus 18 on both sides. Negative 6x equals negative 30. And so divide both sides by negative 6, you're going to x equals 5. So now writing it as a point, your solution or your answer is going to be 5, 6. And so looking at the graph, it intersected at 5, 6. So concluding today's lesson, we solved a system of linear equations using both the substitution method and the elimination method. Now the strategy for the substitution method is you want a variable by itself. And once it's by itself, you can plug it in the other equation. And then what are the strategies for elimination? You want the variables to be opposites, meaning one positive, one negative, and they have the same coefficient. Now, if they're not opposites, you're allowed to multiply an equation by a number to make it into the opposites. And guess what? Sometimes you may have to multiply 2 equations by a number to make them opposites. This does conclude our lesson. If you have any other questions, please leave them in the comments.